So the next question that we have is find remainder when this expression is divided by this expression, and then we need to find a remainder. Okay, so now this expression x square minus 1 can be written as x plus 1 into x minus 1. A square minus b square is a plus b a minus b, so this can be written in this way. Now if you look closely at the expression, you will find what the thing that is given here is. It is really a question on divisibility. We have read that a cube plus b cube equals to a plus b into a squared minus ab plus b squared. Similarly, every cube expression that is a odd expression can be written in this way, like a to the power 5 plus b to the power 5 can be written as a plus b a to the power 4 minus a b cube plus a squared b squared minus a I'm really sorry, not ab cube, this will be a cube b, a square b squared, then ab cube plus b to the power 4. Okay, so this is the expression that we get. We have already read this. So in the same manner, x to the power 2013 plus 1 can also be written. This will be x plus 1 into x to the power 2012 minus x to the power 2011 plus x to the power 2010 minus x to the power 2009 in this way. So you see that x to the power 2013 contains a term that is this. So when this and this will be divided, the remainder will be what? 0. Okay. Now we come to the next question. The next question tells us that one root of, now we have given the quadratic equation 14x plus 8 equals to 0. We are told that one root of this is 6 times the other. It is very easy question. So if one root is 6 alpha, another root is alpha. Really easy. So 7 alpha, 6 alpha plus alpha will be equal to 14 by k. And 6 alpha square will be equals to 8 by k. Okay, now we can take really simple steps to find k. What we will do is replace this alpha square with k. So we get that alpha is equals to 2 by k by cutting this, dividing this. So alpha square is equals to 4 by k squared. So we put this in this expression. When we put this, 6 into 4 by k squared equals to 8 by k. So then we get the final expression that k gets cancelled. 24 by 8 equals to k, and k is equal to 3. So this is the solution. So now we find this question that ax square plus bx plus c has two roots, and those are alpha and beta. And we are required to find alpha beta square plus alpha square beta plus alpha beta. What will be the value of this? Now we find that it is really similar. Look, why? Because every expression has alpha beta terms in it. So alpha beta can be taken common. So alpha plus beta plus 1. From this, the expression has got a little twisted. The beta will be here because we take alpha beta common, and the beta, extra beta is here, and extra alpha is here, and plus 1. So now we can really easily solve it, because we know alpha plus beta is minus b by a, and alpha into beta is c by a. So minus b by a plus 1 into c by a. So this becomes what? A minus b by a squared into c. This was easy. Now we have another question, that is x cube minus 2x squared plus 3x minus 4 is 0. So we are required to find the value, and this has three roots, alpha, beta, gamma. We are required to find alpha square, beta square. plus beta square gamma square plus gamma square alpha squared. What is the value? Now this is also a little application of this formula, that a plus b plus c whole square gives a square plus b square plus c square plus 2ab bc ca. This is its application. So if we take a is alpha beta and b is beta gamma and c is gamma alpha, okay, we find that alpha beta plus beta gamma plus gamma alpha is whole square, and this is the required expression. So I am writing required exp plus 2 into ab. So what will be it? This alpha beta squared gamma. Bc, what will be this? Alpha beta gamma squared, okay, plus ca. So what will be the alpha squared beta gamma. Now what you can do is simplify the expression. You already have this term. Where do you have this term? Here. So two expressions taken together, this will be 8. 3. So what is it? Two expressions taken together. So 3 squared is equal to our required expression plus 2 into, look, we can take alpha beta gamma common from each of them, and it will become, if I take alpha beta gamma, this will become beta, this expression, plus this expression will become gamma, and this expression will become alpha. So do you have this expression? Yes. Do you have this expression? Yes. So let's find the expression. What is the value of this? All the roots combine this minus of minus 4, because 3 roots are being taken. So 3 square equals to required expression plus 2 into 4, right? 4, and the addition of each of them. We know how to find the addition. This now 1 is taken, so minus of minus 2 by a, so 2. So 3 squared minus 4 to the 8 was 16, which is the required expression, which will come out to be 9 minus 16 minus 7, which is the solution. Now we have another question which is related to the transformation of the equation, right? So we have already done some a quite complex question regarding transformation, but we can do this. X square plus px plus q, this is a quadratic equation that is given to us. This is the question, and we are asked to find an equation whose roots are, and these equations roots are alpha and beta. We need to find the equation whose roots are negative 1 by alpha and negative 1 by beta. We need to find this equation. Okay, so what we will do is, it's really simple. What we do, we just put x nu is equals to negative 1 by alpha. Okay, and so alpha will become 1 by x nu, negative 1 by x nu. So what we'll do is, since alpha is the equation of this question, so this expression negative 1 by x nu is also the root of this question, of this expression. So we will write this expression alpha squared, that is negative 1 by xn squared plus p by negative 1 by xn plus q. This is a new x, so we are considering it to be new x. It is not like anything else. So then we find that this is equal to xn squared minus p by xn plus q. We will simplify this and we will get that this is xn squared and this is xn squared, xn, and this is xn squared. Okay, and this is like xn squared, and so we find a new expression, that is q xn squared minus p xn plus 1. So this is our new equation. Now this is a variable, right? So this is if this is a variable, so this can be also be written as qx square minus px plus 1. This can be also its form. This is equal to 0. Okay. So we have another question. Okay, so here we are said that this the first expression, this expression is divided by this term, and the second expression is divided by this term, and we get, when we divide this term, we get a remainder r1, and we divide this term, we get remainder R2. This is a very simple question that is based on remainder theorem. We know that, for example, fx is a function of x and its value is this. So when it is divided by x plus 1, so we do not actually divide by x plus 1. From the remainder theorem, we know that its remainder will be equal to f of minus 1, because x plus minus 1, x plus 1 equal to 0, then f of minus 1, this will be the remainder when we divide it. So we will use a similar concept here, okay? So when x plus 1 is divided by this expression, what we will get? We will get an expression that is minus 1 cube, I think it was x squared. This is a squared expression. So plus 2 into minus 1 squared plus 5a minus 7, and this is equals to R1. And similarly, what is R2? R2 is this. You have to just put 2, and you don't need to actually divide. You just need to put 2, and then you will get the remainder. So what will be R2? 8 plus 4a minus 24 plus 6. This will be R2. And we are given that 2R1 plus R2 equals to 6. What do we get here? We get here minus 1, and this is 1. So 5a minus 7 minus 6, 5a minus 6. 2 into 5a minus 6 plus R2. R2 comes out to be something like 14 minus 10. 4a minus 10. And that is equal to 6. So here, from here we can find the value of a. 10a minus 12 plus 4a minus 10 is equal to 6. So 14a, and that will be equal to 28. So a will be equal to 2. You get that? You don't need to actually divide that. Why this is working? Because fx, if it is, it will be x plus 1 into qx plus some remainder. And if x plus 1 is already a factor of fx, then when you will put minus 1, this remainder will automatically turn into 0. But if it is not 0, when you will keep minus 1, this expression will become 0, because minus 1 plus 1 equal to 0 into qx. So what will remain? Just the remainder. So when you put f of minus 1, just the remainder will remain. So you do not need to do actually anything from your side. We can just use the remainder theorem and we will get our answer. Again, I am telling that fx equals to if any expression is given and you need to divide by that, that will be x plus anything, a, b, c. This can be positive or negative. If a is negative, then x minus a, anything can be. And this is there, an expression of x plus r. So if you want to find the remainder when x plus a is divided, when x plus a divided is divided, that is, I mean to say that fx by x plus a, then you can just put of f of minus a. The value will be same as the remainder, because if you put minus a here, what will happen? The expression will turn into 0, right? And just this remainder will be there. And this is what we have used. This is the remainder theorem.